Every year, trillions of gallons of water falls from the sky. Some of it flows into rivers, some of it collects in lakes, some of it evaporates back into the atmosphere, but a huge chunk of it simply disappears into the ground. For many people, it just looks like the dirt and plants suck it up. But that water really doesn't stop there. Right now, beneath your house, beneath your workplace, beneath the road outside, water is traveling underground. In some places, it may be slowly squeezing through tiny pores in the rocks. In others, it may be flowing through caves large enough to walk through. And depending on where you live, there might even be a river beneath your feet. When most people picture groundwater, they imagine a giant underground river, a hidden lake, maybe even an enormous cave completely filled with water. Things you might see in a Minecraft cave. And to be fair, those do exist, but they're surprisingly rare. Most groundwater doesn't flow through giant tunnels. Instead, it moves through the rock itself. To most people, this sounds counterintuitive because rock is supposed to be solid, but many types of rocks are actually filled with tiny pores and fractures. Think of a sponge. From a distance, it appears to be one solid object, but inside, it's full of empty spaces. Many underground aquifers work in the same way. An aquifer isn't usually an underground lake. It's more of a gigantic water-soaked sponge buried beneath the surface. Water occupies countless tiny spaces between grains of sand, gravel, or rock, and slowly moves through them over time. To understand how this truly works, let's follow a single raindrop. Since it's been raining a bunch in the United States, let's start there. Imagine a storm passing over Kentucky. One raindrop lands on a grassy hillside. Slowly, it soaks up into the soil and begins moving downward due to the force of gravity. It passes between grains of dirt, through small pockets of sand, and deeper into the ground. Eventually, it reaches something called the water table. The water table marks the point where the ground becomes completely saturated with water. Everything below this level is filled. Once our raindrop reaches that zone, it officially becomes groundwater. And this is where its journey becomes surprisingly slow. Unlike rivers that can move several miles per hour, groundwater usually only moves a few feet per day. In some places, it travels even slower, kind of like the Yuki Tsunoda of water. A raindrop that falls today might not emerge from the ground for years, or decades, or even centuries. Due to this slow movement, not all groundwater is young. Some groundwater is ancient, and I mean really ancient. In some parts of Australia, scientists have discovered groundwater that is more than 1 million years old, called the Great Artesian Basin. Think about that for a second. That water entered the ground before the pyramids were built, before the Roman Empire, before most of recorded human history, and has been moving underground ever since, very, very slowly. By analyzing dissolved chemicals and radioactive isotopes, scientists can estimate how long water has been underground. But what about those underground rivers? Well, this is where Kentucky becomes interesting. Much of Kentucky sits on top of limestone, and limestone has this strange weakness. Rainwater naturally absorbs carbon dioxide from the atmosphere and soil, making it slightly acidic. Over thousands of millions of years, that weak acid slowly dissolves the rock. Tiny cracks become larger cracks become tunnels, tunnels become caves, and caves finally become entire underground river systems. This process created Mammoth Cave, the largest known cave system on Earth. More than 400 miles of passageways have already been mapped, and scientists believe many more remain undiscovered. Inside these caves, groundwater behaves very differently. Instead of slowly squeezing through microscopic pores, it can flow through underground rivers, actual rivers, hidden beneath the surface. Scientists have even performed dye tracing experiments by pouring harmless fluorescent dye into sinkholes and streams. Days later, the dye emerges from springs miles away, revealing the exact route the water took underground. It's essentially a way of mapping Earth's secret plumbing system. Eventually, every groundwater journey comes to an end. Our raindrop may emerge from a spring. It may seep into a creek. It may end up in a river and continue toward the ocean. Eventually, it evaporates back into the atmosphere, where the entire cycle begins again. And that's important because groundwater isn't separate from rivers and lakes. It's connected to them. Many rivers continue flowing during dry periods because groundwater is constantly feeding them from below. Without groundwater, many rivers would shrink dramatically during droughts. Nearly a third of all readily available freshwater on Earth exists underground, and billions of people rely on it every day. The water we drink, the water farmers use to grow food, the water that feeds springs, rivers, and wetlands. Yet, most of it remains completely invisible, which is probably why so many people forget it exists. So, is there really a river beneath your feet? All I can say is, Maybe.